When naming acids, the first thing to do is determine whether it's an oxy acid or a non-oxy acid. Remember, for the purpose of this class, anytime a molecule or a compound starts with an H, we're going to assume it's an acid. Your homework will want you to write AQ behind it. So when it's in the aqueous form, then it is an acid. But for our purposes, if it starts with an H, you can just assume it's an acid. Okay, so then we want to determine if it's an oxy acid or a non-oxy acid. The difference between an oxy acid and a non-oxy acid is whether it contains oxygen. So for our first example, HNO3, there's 3 oxygens, which means it's an oxy acid. If it is an oxy acid, that means you just start right in with the prefix, or right in with the name of the polyatomic molecule. In this case, NO3 is nitrate. So we'll just start in with the base name of nitrate, which is nitro. Now, if it's an oxy acid and it has an ate ending, when it's in its acidic form, we give it an ic ending, because if you ate an acid, it would be icky. If it has an ite ending, then we give it an us ending. So since this is nitrate with ate ending, the acid gets an ic, nitric acid. Okay, let's look at our next example. This one starts with an H, so it's an acid. It is not containing any oxygen, and so it is a non-oxy acid. If it's a non-oxy acid, you need to write a hydro prefix. So we'll start with hydro, and then the base name of the element that is not hydrogen, just this one, which is nitrogen, so we're going to say nitro, again, the base name. And now if it's a non-oxy acid, it always gets an ic ending, so this is hydronitric acid. The difference between nitric acid and hydronitric acid is that nitric acid contains oxygen and hydronitric acid does not. Let's look at our next one. So we know it's an acid because it starts with H, it contains oxygen, makes it an oxy acid, which means we start right in with the base name of this polyatomic ion. So we'll start with sulf. Now this is sulfite, SO3 is sulfite, SO4 is sulfate. So sulfite has this ite ending up here, which means the acid gets the us ending. So this is sulfurous acid. Sulfur and phosphorus are kind of funny, where sometimes the base name is just sulf and sometimes the base name is sulfur. If you confuse those, it's not a big deal. If you write sulfurous acid, that will be just fine. Okay, and then the last one, acid, because it starts with H. There's no oxygen here, which makes it a non-oxy acid, which means we have to start with the prefix hydro. And then the base name of this element, which is fluorines, so we put hydrofluor. Since it's a non-oxy acid, it automatically gets the ic ending, so this is hydrofluoric acid. Let's try going the other way as well. So if we have the name, let's practice writing the formula. Our first example here is hydrocyanic acid. Since it has that hydro prefix, we know that it doesn't contain oxygen. We'll start with every acid. The first thing you write is hydrogen, because every acid starts with hydrogen. And then cyanic, this is our ion that goes with the hydrogen. Cyan is the base name of cyanide, which is one of your polyatomic ions. So we'll write that polyatomic ion. And then we need to make sure that these charges cancel. So hydrogen has a +1 charge, cyanide has a -1 charge. So in this case, that does balance out. And the formula for hydrocyanic acid is HCN. Let's try the next one. You notice there's no hydro prefix, which means this acid is an oxy acid and it contains oxygen. So it's an acid So we start with H, and then we know that this phosphoric is a polyatomic ion because it has oxygen in it, because it's an oxyacid. We know it's PO something. Since it has an ic ending, it has to correspond with the 8 polyatomic ion. Phosphate is PO4, 3 minus. Hydrogen is 1 plus, so now we need to balance these charges out. So H3PO4. This is phosphoric acid. The next one has the hydro prefix, so we know it's a non-oxy acid, meaning it doesn't contain any oxygen. It's an acid, so we'll start with H. There's no oxygen, so it's just going to be phosphorus. Here, phosphorus is also 3 minus, hydrogen is 3 plus. So to balance those out, we have H3P. This is hydrophosphoric acid. Now you'll notice that phosphoric acid here and hydrophosphoric acid here sound similar. The only difference is that phosphoric acid contains oxygen and hydrophosphoric acid does not. Okay, and then let's look at our last one. This one starts with hypo. Now this is a common mistake. This is not hydro, so it's starting right in with the base name of the polyatomic ion, which means it's an oxyacid. So we start with our H, and then hypochlorous comes from hypochlorite. So you have to extrapolate from chlorate, which is ClO, to chlorite, which is ClO2, to hypochlorite, which is ClO. It still gets a -1 charge. Hydrogen still gets a +1 charge. So hypochlorous acid is HCl.